Okay, hello everybody. Today's objective is we're going to be understanding all parts of a quadratic function, which I know you definitely did last year. So we have some key terms that we're going to go through first here. These should be in your notes. Let's go through these key terms. What is a quadratic function? It's a function in the form where you have your x definitely squared. You could have a bx, you could have a c, you could have any form of this as long as your exponent there is squared. That makes it a quadratic function. What's a parabola? Well, it's the graph of a quadratic. So that's the name. We could have our happy parabola, we could have our unhappy parabola. Now we're getting into a little bit more specific things or parts of a quadratic, of a parabola. What's a vertex and what's an axis of symmetry? Well, the vertex is a point, either it's the highest or the lowest on a quadratic. So I'm going to make a little x and y axis here. And if I was to make a quadratic, however I'd like, let's say I do it like this. Let's go like here. Alright, here's my quadratic function. The vertex, here it's the lowest point. It's where the curve moves up high to low or low to high. This is my vertex. Axis of symmetry. So this is a line, specifically a vertical line, that goes through the vertex. So I'll make a dotted line going through the vertex. This is my axis of symmetry. Why is it symmetry? Because if I was to actually fold this piece to this piece, it would match exactly on both sides there. What's an x-intercept and a y-intercept? An x-intercept are points on the graph that cross the x-axis. And you find x-intercepts, so this would be an x-intercept here, this would be an x-intercept here. And you would find them by factoring. What's a y-intercept? Y-intercept is a point on the graph that crosses the y-axis. So we have one right here, it's crossing here on the y-axis, that's my y-intercept. If I was to actually name the point, it would be 0, comma, wherever it is on the y, whatever point that is. Alright, there are different forms of a quadratic function. We have our standard form, which we all know, f of x equals ax squared plus bx plus c. You could also have a vertex form of a quadratic function, and it's written entirely different. It's written as a times x minus h squared plus k. The h and the k are the vertex here. We're going to get more into this when we start doing conics and learning about different positions, but for now we're going to be sticking with the standard form. Okay, now we're going to be getting into specific formulas for a quadratic function. We want to actually know how to figure out the vertex of a quadratic on the parabola, that high-low point, and this is the formula. So this is real important for your notes. We're taking our b, negating it, negative b, and all dividing it by 2a. That's to get my x of that point. And I'm going to take that answer and do f of that point to get the output for that vertex. The axis of symmetry, which is the line that's going through the vertex, is just taking the x part of that vertex, so you already have the answer, and making it x equals because it's a line going through the x part of the vertex. So we have two practice questions that we're going to take a look at. We're going to find the vertex, we're going to find the axis of symmetry, and we're going to figure out if a parabola opens up or if it opens down, happy or unhappy. Alright, so if your equation is not in this form, you need to move things around to make sure that it's ax squared plus bx plus c. So let's define on here what's the a, what's the b. So a is -3, b is 6. I don't need the c for this formula, so I'm not even going to write it out. We have our vertex formula as -b over 2a. So let's go ahead and plug in our numbers. So our b here is 6. We're going to do -b, so we're going to make it -6 over 2 times, what's our a? -3. So I multiply the bottom, bring over the top, -6 divided by -6 gives me 1. So I have the first part of my vertex point right here. Now I need to figure out the output. So what do I do with this answer 1? I'm going to do f of 1. So that means I'm going to go to this equation and I'm going to plug in 1 for the x. So I got -3 times 1 squared plus 6 times 1 plus 1. Please be careful, do your order of operations here. So I'm doing my exponent first. So I got -3 times 1 plus 6 plus 1, -3 plus 6 plus 1. I got 3 plus 1, so I get the output to be 4. So my vertex here is 1, 4. Alright, what would be my axis of symmetry? Well, I would take the answer that I got for -b over 2a and put x in front of it. Let's erase this. So I got my axis of symmetry as x equals 1. Does this parabola open up or does it open down? So to figure out if a parabola opens up or open down, you're looking at what's the sign of that a number. So if a is greater than 0, meaning positive, it's going to open up. If my a is less than 0, so it would be negative, it would open down. So for this one here, because a is -3, my answer B opens down. Okay, let's take a look at number 2. F of x equals 2x squared minus x plus 2. We want to find our vertex first. So let's go ahead and define our A, 2. Our B, here is the imaginary little 1 there, and it's -1. Now I'm going to write down my vertex formula, which is the -b over 2a. Let's plug it in. -b is opposite of this one, so it's going to become +1 over 2 times 2, which is the a. So my x point kind of is yucky, right? It's a 4th, or you could write it as 0.25. I need to take this answer and go ahead and plug it in. Oops, 0.25, comma. Plug it in this equation here. So I'm doing f of, I'm going to have it as 0.25. So I'm going back in here and plugging in 0.25 for the x. 2 times 0.25 squared minus 0.25 plus 2. So my suggestion for you here is to take your calculator and use your calculator to plug things in. Just be careful of your order of operations again. So when I did it in my notes, I got it to be 0.125 minus 0.25 plus 2. Go ahead and subtract and add, and I got it to be 1.875 as my decimal here. So this is a weird vertex, 0.25, comma, 1.875. Okay, now we need to go ahead and find the axis of symmetry. So the axis of symmetry again is taking the x of the vertex and just putting x in front of it. So I'm going to erase this. So my axis of symmetry is x equals 0.25, or a 4th. Does this parabola open up or does it open down? We're looking at the A value here. This A is positive, so that means this parabola opens up, a happy face. Okay. All right, now we're going to take a look at graphing a quadratic. So here we're going to go through what we just did over on the previous board there. We're going to find our vertex first. So don't forget the formula. Then we're going to find our axis of symmetry. And then we want to know exactly where is this crossing on the x-axis. We're going to find x-intercepts by factoring. So we have to review factoring a little bit. Alright, so let's get our vertex first. Our A here is 1, imaginary 1. Our B here is 2. Let's plug it in the vertex formula. So we get it to be negative 2, because B is positive, over 2 times A, which is the 1. Negative 2 over 2. Here I got my x part of the vertex as negative 1, comma. Now I need to go and plug negative 1 into the original equation, f of negative 1. So negative 1 squared. Do our order of operations. This is positive 1. Minus 2 minus 3. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So my vertex here is negative 1, negative 4. My axis of symmetry is x equals negative 1, right? And now I want to talk about finding those x-intercepts by graphing. Alright, so we are going to take the equation x squared plus 2x minus 3, and hopefully everyone remembers to find x-intercepts, the output is y because it's on the x-axis, 0. We need to factor this. So who remembers how to factor a trinomial? We're looking for the factors of negative 3. What multiplies to negative 3, so it's a positive and a negative, and at the same time adds up to positive 2. And hopefully we all remember we have 2 sets of parentheses here. We have our x's because it's x squared. So what would be the signs for the 3 and the 1? We want it to be able to add to positive 2, so that means the 3 has to be a positive, the 1 has to be a negative, and we could check. This is negative 3 when I multiply, and when I add that together, it does give me 2. And then we separate these things, right, to find our x's. X plus 3 equals 0. X minus 1 equals 0. We solve each of these. So one x-intercept is negative 3, and the other x-intercept is 1. So we need to now graph all these points. So make an x and a y line. Let's see, it's going all the way down to negative 4. Over this way. My x-axis, my y-axis. Alright, so let's plot our vertex first. Negative 1, negative 4, which is here. Let's plot our x-intercept. So I have negative 3, 0. And I got 1, 0. 1, 0. Negative 3, 0. Now we know it's going to open up because this is positive. So it's a happy face. And you can see that obviously. And then if I wanted to have my axis of symmetry line, that would be going down this way like this. This would be my axis of symmetry. X equals negative 1. So you're just doing a brief sketch of a quadratic equation.